Alright, so this is around November 2nd, 2020. So I'm not going to read this to you. These are the steps. I'm probably going to talk about them as I do this example down here. So I just think it's easier just to get started right with a problem here. Optimization. So you've done optimization problems before in your previous probably 2 math classes. Optimal meaning the best solution. So trying to find the minimum or the maximum of a word problem. You probably did a box example where you tried to find what's the minimum amount of surface area to enclose the maximum amount of volume. That's a question that businesses should be interested in to minimize their cost in packaging. So let's see what we're doing here. So find 2 non-negative numbers whose sum is 16. Okay, so we can start this off right now. So we're trying to assign variables 2 non-negative numbers. So we can call those, I'm going to call them x and y. You could call them n1 and n2 for number 1 and number 2. But whose sum is 16. Now, make a sketch. There's no sketch to show here really. So the sum is 16. So we have x plus y equals 16. And whose product is as large as possible. So now that's step number 2. So step number 2 is our primary equation. So I usually use a capital letter for whatever they talk about. So if it's P for profit, or C, trying to minimize cost, C for cost, or V for volume, trying to maximize volume. So here we're trying to find the product that is as large as possible. So that's going to be a capital letter P, and the product of those 2 numbers is just going to be x times y. Okay, as large as possible. So we're trying to maximize that equation. Okay, so step 3. So if I'm color coding these, the blue was step 1, red was step 2. So I'll go purple to step 3. So step 3 is we want to get the primary equation down to a single independent variable. So P in terms of one variable. So I'm just going to get rid of y. So y is going to be 16 minus x, and then I'm going to use substitution. So that's going to be P of x, because I've altered the equation down to just x's now, and a constant. But there you go. Now you may want to rewrite that. So if you distribute that, that's going to be negative x squared plus 16x. Okay. Now, step 4 says to step 4. That's kind of a dark green, but determine the minimum or maximum using critical values. So to use critical values, we need to take the derivative. So we're going to take the derivative of this with respect to this function. And so that's going to be negative 2x plus 16. And if we look at that here, that would be 8, be our critical number. Now, set that equal to 0. We could factor out a negative 2. That would make that x minus 8. Be careful there that you don't get rid of that completely. That could cause a problem. Anyway, in some situations. So if we do a test value here, 7, if we plug a 7 in there, that would be a negative times a negative, that would be positive. If we plug a 9 in there, it would be a negative times a positive, that would be negative. So what that means is we have a relative maximum at x equals 8. Now, because P prime of x changes from positive to negative. So a lot of students leave this part off, but that's the calculus part. So don't leave the calculus part off. Now, there is something I need to go back and think about, and that is we're supposed to test the endpoints says don't forget to test the endpoints. So this is like a candidate table when we found the absolute minimum or maximum. So to go back and do that, we need to think about a couple things. What's the domain of this situation? So the domain is going to be non-negative. So the lowest the number could be would be 0, and the highest the number would be 16. So we have to go from 0 to 16. So we've got our candidate table. So we're going to do x, y, and the product. So that's what we have. So if x is 0, then y would be 16. We just found out that we have a relative maximum at 8. So if we plug 8 in for x, we find out that y would be 8 also. And then if x was 16, that would be the other endpoint, then y would be 0. Now, this seems kind of ridiculous, but if we multiply it together, that's going to be 0, that's going to be 64, and that's going to be 0. So the question says find the two numbers. So the two numbers are going to be when x is 8 and when y is 8. Now, most of the time, the endpoints are not the answer, but it is possible that they could be. You may have done some of this with systems of equations back in Algebra 2 Honors, maybe, where you graphed some lines and you got an area of a region and you tested the endpoints. I remember teaching that a while back, and maybe in pre-calculus. I remember a question about snowboards and skis and how many should the company make. And it's possible that you might make more profit by not having any, just making snowboards. So that's a case where the answer would be the endpoint. Anyway, I don't know if we have a question where the endpoint is the answer here. That probably would be a good idea, but okay, so let's keep going here. So you can go back and read over those comments on the side there if there was anything. So let's just do another one. So this is like page 217, 20 and 21. It's highlighted as a test question, so don't skip those in your assignment. Don't skip test questions in your assignment. That doesn't make any sense. I mean, it's not a good idea. Okay, so we have a box here. All right, so I thought I'd save us a little bit of time. Drew this out, drew the picture. So if we do that, actually, I want to do that in blue. Oops. Oh, I grabbed the purple there. Anyway, so open rectangular box made it from a piece of cardboard. We're going to cut the corners out, fold those up, tape it up, and make a box. So hopefully you remember doing a question like this in Algebra 2 Pre-Calc. How long should the size of the square be to create the box of the largest volume? So that pretty much tells you the capital letter to use, V. Now all the variables are already in terms of x, so I can just say V of x. So the volume there. So if you think about it, if you fold the sides of that up, think about what the dimensions of that would be. So we would have this. I guess I could have drawn this before as well. But it's going to go back and down and across here and back and down. That's a little bit awkward. I should have drawn that a little bit further back, but alright, something like that. That should have been dotted, but not the best, but you get the idea. So if you cut that out and fold that corner up, hopefully you can fill in the height of that. You realize that'll be x. Again, you could pause this and try to get a little of this yourself. So if you think about this side of the box, it's 5. But you're cutting x off of both sides, so that's going to be 5 minus 2x. And this will then be 4 minus 2x. Okay? So, again, I was trying to color code this, but I'm not doing a very good job. The formula is actually in red. So, let's formula in red or the derivative? Yeah, formula was in red. And then it was purple. This isn't working out very well with my colors here. So the formula for the volume here is going to be x times 4 minus 2x times 5 minus 2x. Okay. So if we multiply that out, that's going to be 4x squared times x. That's 4x cubed. And if we, in the middle here, it's going to be negative 10, negative 18, x squared. And for the number there, that's going to be 20x. So that's what we'd get if we multiplied all that stuff out. Okay, so you're supposed to draw the situation, label as much as possible, come up with an equation that has a capital letter on one side. Sometimes you have to do a system of equations to fill out this part, but we didn't need that here. Then our next step is to take the derivative and find any extrema. Now, another thing that we could have done all along here was think about the domain. That's something I kind of forget sometimes. So the domain of this situation, what's the smallest square we could cut out there? Well, it would have to be greater than 0. So it could be really tiny, but that probably wouldn't make any sense because the volume would be. And then what's the most we could cut out? Up to, well, if you think about this side, this is 4. And if you're cutting squares off both sides, that would be 2. So it would have to be less than 2, because if you cut out a square of 2, then you would be cutting off this side completely and the other side. And then you would just have a narrow piece of cardboard in the middle. So that doesn't really make sense. So 0 to 2. All right, so back to this, we're going to take the derivative. And that's going to be that. And we can factor a 4 out of there and set that equal to 0 to find our critical numbers. Okay, so this is not going to happen on the AP Calculus test because I don't think I've ever seen a quadratic formula. But that doesn't factor. I'm looking through that. That's prime, that's prime. There's no combination of those going to get us a 9 in the middle. So it's good practice. We might need that for something else somewhere. But so x equals the opposite of b plus or minus square root of b squared minus 4ac. And because this is the sign, we could divide both sides by 4, we'd be okay. But minus 4ac. We want to be careful about losing the sign of the number if we had that. So this is going to be 81. What is that? 2060. So minus 60. So that's going to be root 21, which doesn't simplify. So we're going to have 9 plus or minus root 21 over 6. Okay? So if we think about that, root 21 is 4 point something. So we're going to have 9 plus or minus 4 point something over 6. So 9 plus 4 is 13. So that'd be 13 point something over 6. 9 minus 4 point something is 4 point something. So 4 point something over 6. Now 13 over 6 is 2. And 2 is outside of our domain. So that's not going to work. So what we need is the minus. So on our chart right here, this is actually going to be 9 minus root 21 over 6. Okay? So that's about 2/3. So if we test a 1, plug 1 into the derivative, and where do we want to put that here? 1, if we plug a 1 in here, that's going to be negative. So that's going to be negative over there. And be careful about always assuming that it's going to alternate, because it doesn't always alternate. But if we test something out, so maybe 1/2. So 1/2 half of this is negative 4.5. That's going to be positive. That's already more than that, so that is going to be positive. So my test points there were 1/2 and 1. That was the test points that I used on those intervals. Okay, so what that means is we have a relative maximum at that, I don't know if I can fit that in here, 9 minus root 21 over 6, because v prime of x changes from positive to negative. Okay, so our last step there would be to test the, to do the candidate table. So it doesn't really make sense if you think about it. It can't be 0, but 0 and 2, and then 9 minus root 21 over 6. So the maximum volume, I didn't calculate those, but it's going to be when that's that feet. How long should the side of the square be? It should be 9 minus root 21 over 6 square feet. Like I said, that's a bit, it's not going to be a quadratic formula. They'll just be, it'll factor or whatever. Okay, so let's try another one. So blue. All right, let's see if I can match my colors this time. Now, find the point on the parabola closest to, so the parabola here has a vertex of 0, 9. It's been shifted up 9, reflected over the x-axis and shifted up 9. The normal pattern is over 1, down 1, over 1, down 3, over 1, down 5. And there we go. I'm going to finish that up. Alright, so the blue is kind of everything that we know about the situation. So we graphed the parabola, we've got the point on there. The question is, find the point on the parabola, x, y, that's closest to 3, 9. Okay, so if you think about that, that's going to be the distance formula, the closest point. So if we fill that out, that's going to be x minus 3 squared plus y minus 9 squared. Okay, so a couple things. First of all, if we're trying to find the maximum of this, or the minimum, sorry, the minimum, if we're trying to find the minimum of this thing, hopefully everybody realizes that if we find the minimum of this, the inside there, the radicand, then if we find the minimum of that, then we'll be finding the minimum of this. So that's the radicand, so I'm going to use r. Okay. Also, we need to get it down to a single variable, so I want to change it all to x. Okay. So that's going to be x minus 3 squared plus, now hopefully some of you have an idea of how we can get that down to just x. Clearly we want to get rid of y, and y is equal to this. So we can substitute that in there. So that's going to be 9 minus x squared minus 9 squared. Now, so what happened to the radical? How'd you get rid of the radical? We just left it off. If I'm trying to make this, I might have said it backwards. I don't know if I said it biggest, but it's minimum. So I'm trying to make this as small as possible. It works either way. If I'm trying to maximize the distance, then I want this to be as big as possible underneath, inside here. If I want this to be the smallest, then I want this to be the smallest possible. I don't need the square root. I'm just trying to find out what's going to make this the biggest or the smallest. And that's going to be the same whether the square root's on there or not. Okay. So here, these 9s are going to cancel. And we're just going to clean this up just a little bit before we move to the next step. So that's going to be x minus 3 squared. And then negative x squared, that's going to be x to the 4th. Okay, so draw the picture, label everything. Come up with an equation. If you need to, substitute in the equation, get it down to one variable. Now do the calculus, take the derivative. So the derivative of that is going to be r prime. And now you could multiply this out, but you don't need to. Just do the power rule on that. So bring the 2 down, and x minus 3, and that's going to be 1. Check to see if you use the chain rule. You don't. If it was 3 minus x, we would need to multiply by negative 1, but we're okay. And then 4x cubed here. Okay? So if we set that equal to 0, that's going to be 4x cubed. Now we do want to multiply this out, so that's going to be plus 2x minus 6. Okay, so first thing we could do is we could multiply this whole thing by 1/2. And that doesn't change the sign, so that shouldn't be a big deal. So that's going to give us this. Now, again, this is not going to be on the AP exam. And you guys, well, why are you doing it? Because I want to give you a well-rounded calculus class and not just skip the stuff that's not going to be on the test, because you might need this stuff for other classes. They do expect you to know all of these things because you've had these courses before. So we're trying to break this down to find those numbers to do our sign chart, positives and negatives. So what we're going to do is P over Q, or Q over P. I don't know if you remember that, but so what we're going to look at, so let's look at, so P is the leading coefficient, and Q is the constant. Okay, it doesn't really matter that it's negative. We can just focus on 3 because we're going to do plus and minus of all of them anyway. So what we have here is called the possible rational roots. Possible rational roots. Okay, and those are Q over P. So first of all, the factors. So it's the factors of 2 and the factors. So that's going to be 1 and 2, and this is going to be 1 and 3. So that's not really that big of a deal. So we're going to get plus and minus 1, and because that's a factor, 1 over 1, because we can list the factors. P is actually 2, but the factors of P are 1 and 2, and the factors of Q are 1 and 3. So if we put 1 over 1, we get 1. If we put negative 1 over negative 1, we get 1. So plus and minus 1 both work. Then we can do 2. No, it's just Q over P, not P over Q. So it's either going to be 1, or it's going to be 3, or it's going to be 1/2, or negative 1/2, or 3/2. Okay? So we get all those possibilities. So then we use the remainder test. So, or the factor test. It's kind of the same test. You plug the number in, and you see what the remainder is. If the remainder is 0, then that's a factor, and that's called the factor test. I think it was a long time ago. So we usually start with the easiest ones to plug in. So we're going to try 1 and then negative 1 and then move our way across to the more difficult ones. So if we plug a 1 in there, that's going to be 2 plus 1 minus 3. So that equals 0. So that works. So that means that we can do synthetic division or long division if you prefer, and we can divide out 1. Okay, if this is blowing you away because you don't remember it, it's not that big of a deal, but it's not like you have to memorize. Don't study this for an hour. I'm just hoping this jogs your memory and you're like, yeah, I kind of remember that. I've seen it before. Okay, so 2. Now, hopefully, I would say that you guys remember something here on synthetic division or long division, either way, right where my pen is pointing. We have to put a 0 placeholder in there for x squared, and then 1 and negative 3. So we bring this straight down and we multiply, then we add, then we multiply, then we add, then we multiply, and we add. Now that better be a 0 or you did something wrong. That's the whole point. That's why we did it. So 1, that means x minus 1 is a factor, the opposite. And then we're going to have 2x squared plus 2x plus 3. Now, you might think, man, did you put 2 quadratic formulas on the same page, Mr. Christensen? That's messed up. So let's look at the discriminant. The discriminant is the part of the quadratic formula underneath the square root, b squared minus 4ac. So b squared minus 4ac. I hope you can tell from that immediately that's going to be negative. that means that that does not have any real roots, so we don't have to worry about that. So the only thing we really have to look at here is 1. Now, I didn't really talk about the domain of this. The domain, again, I kind of tend to forget that. The domain, we know that it's more than 0. And here, this is 3. So as it moves here, we know that that's closer to, I mean, this is, well, it's closer than 3. So we're kind of just eyeballing that and approximating that. So back to this, I didn't test that. So if we plug in 1/2, this is going to be positive. If we plug in 1/2, this will be negative. So a negative times a positive is negative. And if we plug in 2, that's positive and that's positive. So we know we have a relative minimum at x equals 1 because r prime of x changes from negative to positive. Okay? So now we can just test that out. The endpoints here are not going to make sense. 0, that's going to be 3, I guess. It's going to be 1, so we're going to plug 1 in there. Point's going to be 1, 8. I mean, it can't be 0. That doesn't make any sense. So the endpoints are sometimes a little bit tricky, but okay. This is pretty ridiculous.